Hello and welcome to java9s.com. I'm Srinivas. In this session, I'm going to talk about the Spring transactions. Before touching upon the Spring transactions, I would like to give some introduction to transactions itself. A transaction is nothing but an unit of work performed within a database management system against a particular database. You have to concentrate on few words here like unit of work. A unit of work is nothing but a combination of few steps. These steps have to be performed at once, or if there is at least one step which fails in performing this unit of work, then the total unit of work or the data that needs to be written to the database have to be rolled back. And so if you look at the transactions, they provide all or nothing proposition. So each unit of work performed should be entirely committed, or if any step fails, the total data has to be rolled back to ensure the integrity of the database. So let me explain this with an example. Say I have a concept known as fund transfer, which involves multiple steps. So first step is to debit your account, then the amount has to be transferred to your friend's account, then finally your statement has to be updated. So all the three steps have to be successful to commit the data to the transaction to the database. So only when all the three steps are successful, we are going to commit the data and persist the final data to the database. But say if the debiting the amount from your account has happened successfully, but transfer to your friend's account has failed, and again updating the statement has done successfully, then it's the data is going to be a very wrong data, and we need to ensure that the transaction is rolled back so that no data related to your debiting the account or updating the statement or anything else related to this unit of work will go into the database and get persisted, because the data is going to be inconsistent. The unit of work has not happened successfully. So the transaction is all about all or nothing concept. All the steps have to get executed successfully, or nothing should be persisted if any one of the steps fails. So if you look at the transactions, there is an acronym known as ACID, which tells about the details about what transactions should take care of, why the transactions have been introduced. Transactions should maintain the atomicity. Atomicity ensures that all operations in a transaction happen or none of them happen. That's what we have discussed, that a unit of work should happen all together, or nothing has to be persisted. The next thing, transaction takes care of the consistency. So because I told you, even if one of the steps fails, obviously the data which we are going to store is going to be inconsistent and incomplete. So the consistency should be maintained. So a transaction ensures that a successful transaction ensures that the consistent data is present in the database, or it is not there in the database at all. Next, the transaction also takes care of isolation. That means when there are multiple users trying to access the same database and table or rows, then the isolation should allow multiple users to work together, but still the the data read and write will be taken care, so that multiple users just don't no, distort the data while working. So transactions should be isolated from each other's work, and this prevents concurrent reads and writes. We'll be looking at isolation in more detail. And finally, durability. That means once the successful commit happens, the database management system should ensure that the data is persisted into the physical storage, so that this data is available permanently forever. So the acid, all these atomicity, consistency, isolation and durability are there, and transactions are there to maintain these principles. So to understand the importance of Spring transactions, we should understand what was there earlier and what was the need for Spring transactions. So before Spring transactions, EJB was considered to be a powerful API offering bean managed transactions and container managed transactions. So a bean managed transaction is a fine-grained transaction level where you can apply transactions at the method level, and container managed transactions are managed the transactions which are configurable in the application server. So this is kind of a declarative transaction. So the EJB offers you both programmatic and declarative transaction management, but the problems is that to work with EJB you need to invest on an application server. So investing on application server is a costly affair, and not all the projects can do that. And another thing is that EJB relies on JTA for transactions. EJB Using EJB itself is a costly affair, and also adds to the maintenance. It increases the maintainability. So maintenance problems. So now let us see the advantages of Spring transactions. It offers both programmatic and declarative transactions, just as EJB. And declarative transactions are very much equivalent to container managed transactions. And please remember, you don't need to have an application server or even web server. So even if you are running a standalone application which connects to a database, still Spring transactions can help you to maintain your transactions as if you are working on a container level transactions. So Spring transactions are very efficient, and they are very lightweight, and they can be used in standalone applications. They can be used in web applications. You don't need to have an application server at all. So there is no need to use Java Transactions API also. And the another advantage of Spring transactions is that it has a wide range of transaction managers defined in its API to help to connect to the different drivers. So you we'll see about transaction managers, and we do have to learn something about the Spring transaction limitations. The first thing is that Spring transactions are good at applications using single database source. If you have multiple database source, then it is recommended to go with distributed transactional management APIs like JTA. So but Spring is efficient at supporting any kind of Java transaction API you're going to use. And as we have said, Spring offers both programmatic and declarative transactions. Now let us see what is programmatic transaction. A programmatic transaction gives you a precise control on the boundaries of a transaction. That means, let me explain this with an example. Say I have a method known as ticket booking here. You can see that if I want to maintain a separate transaction for check availability, I can start my transaction and commit once this step is over, and I can maintain another transaction for the rest of the three steps. That means I have the freedom of introducing transactions and committing the transactions wherever I need. So this kind of programmatic transaction gives a very precise control on where to start and where to end. But there is a drawback in this. One should remember that the total concept of aspect oriented programming was developed to remove this kind of cross cutting concerns outside the code. Transactions are considered to be a cross cutting code. Reason is that if you see this ticket booking, the object oriented analysis and design says that a method should be designed based on its responsibility, and whatever it is supposed to do, it should only do those things. If you look at this method, the steps that are involved here are not just about the ticket booking, it is also starting a transaction and committing transaction multiple times. It is actually affecting the lucidity or the responsibility of this method. So these are considered to be cross-cutting concerns, and using aspect-oriented programming we can remove them from our code but still be able to apply them by configuring our aspect-oriented programming framework using Spring AOP concepts or Aspect-J concept. But for those people who need a huge and very precise control of how their transactions have to be maintained, programmatic transactions are the one which is advised for them. But for those people who want to keep their code clean and maintainable, then declarative transactions is the way. So let us look at the declarative transactions. Declarative transactions are less intrusive and they are defined in a configuration file, and now they can also be defined using annotations. They are based on the aspect oriented concepts. So this gives an advantage of keeping the cross-cutting concerns like transactions out of the DAO layer. And please remember, before going ahead to know about declarative transactions, I recommend you to refer to the aspect oriented programming concept. You can look out for my video Spring AOP concepts by Java 9s. You can read or you can learn from the AOP concepts from that video tutorial. And let us look at the Spring transaction managers here. If you look at the transaction managers, Spring does not directly manage the transactions. Please remember that. Spring transaction API is not there to manage the transactions. It is just there to delegate the transaction details to your transaction manager of a particular platform you are using. So Spring transaction managers delegate the responsibility to platform specific management API. So they are there as a facade to platform specific transaction implementation. So Spring transaction managers are just there to act as a facades. That means they know what is being configured and they know how to communicate with the platform specific transaction APIs. So Spring Transaction managers are good managers in terms of talking to platform specific APIs. And then if you look at different transaction managers that are available, the prominent ones are Data Source Transaction Manager for the JDBC. We have Hibernate Transaction Manager for Hibernate, JPA Transaction Manager for JPA, JTA Transaction Manager for JTA, and we do have CCI Transaction Manager for JCA kind of applications, and we do have JMS Transaction Manager for JMS API messaging source. So any kind of information system or any system which has some transaction level maintenance, we do have some transaction manager to communicate with that. And let us look at these transaction manager configurations on a high level. So if you look at the configuration, I'm configuring data source transaction manager here, which needs a data source to tell about the transactions that needs to be maintained on a particular connection, because the transactions are opened on a connection and data source is responsible to get the connection for us. In Hibernate, it is a session factory that is responsible for getting a session or a connection. So Hibernate Transaction Manager will look out these things. As the same way, we have JPA Transaction Manager and we do have JTA Transaction Manager. Next, we are going to enter into a very detailed outlook of looking at the transactions, and there are 5 things we need to consider, 5 attributes we will be able to give to tell about the behavior of a transaction or how a transaction should behave when applied in the application. So there are 5 attributes we should know about. One is propagation, isolation, read only, rollback rules, and timeout. So a propagation is all about how the current transaction supports the other transactions, or how what are the kind of behaviors a transaction should have, like whether it supports the old transactions or it should not support the old transactions, as kind of propagation rules we're going to look at. So if you look at the propagation behavior, defines the boundaries of a transaction. Propagation configuration tells the transaction manager if a new transaction should be started or can use a transaction that is already existing. So let me explain about the rules. So propagation mandatory. This says that a method should run in a transaction and when nothing exists, exception will be thrown. So already a transaction should already be so any method that you are going to run should already be there with the transaction. So you should invoke this method inside a method which is already having a transaction that is running. Then propagation nested. A method should run in a nested transaction. That means already there are a tree of transactions that would have already started, and this particular method should run in that kind of environment. So but propagation underscore nested behavior varies based on the database. So please refer to the documentation of respective database or liaison with your DBA to get more details on this. Propagation underscore never. The name itself tells it never. It's a strong voice that the method should never execute in an transaction, and if one already exists, an exception will be thrown. Then comes the propagation not supported. You can see that in the name itself it is slightly compromising, like it's just going soft on the rules, not supported. So method should not run a transaction, but if a transaction is already existing, it will be suspended until this method executes. And next, propagation required. So this says that a transaction is required. If one already exists, it will be utilized. If there is none existing, then a new transaction will be created. Propagation requires new. That means the name itself says that a method should always execute in a new transaction. If one already exists, it will be suspended and a new transaction will be started. Finally, we have propagation supports. It's pretty evident with the name itself says that the method really need not have any transaction, but if there is already one existing, it can run in that transaction. So these are all about your propagation rules. So coming to the isolation levels, what is isolation actually? Isolation ensures the integrity of the data. I mean, like when there are multiple users looking out for data, isolation ensures that who should be able to look at the data and who should be able to modify data when they are trying to access the same data at the same time. So the possibilities from the isolation declarations is that there are dirty reads that are possible when transaction reads an uncommitted data. So when you don't set auto commit when you set some attributes, there is a possibility that at some other transactions might be able to read uncommitted data, which is always a problem. So dirty reads should always be avoided, and it is not healthy for the application or the users. Non-repeatable reads. This occurs when a transaction reads the same data multiple times but gets a different results each time. That means you should be able to understand that when a particular transaction is trying to read a particular row for multiple number of times and each time it is getting a new data, that means another thread is updating that particular row. So non-repeatable reads are possible, and then finally the phantom reads are also possible. It occurs when two transactions work on the same row where one updates and the other reads. So every time one transaction is trying to read the data and the other transaction is trying to update it, so the reading transaction will be able to find new rows getting added. So these are called phantom reads. So let me talk about this isolation attributes. Isolation default is the default isolation strategy for a particular data source. So whatever the default kind of isolation level the data source has, it will be used. When you specify isolation read uncommitted, you're particularly telling that the transactions can read the uncommitted data. This will lead to dirty reads, phantom reads, and non-repeatable reads, and you should avoid this kind of data because you're going to read the data which might not be permanently committed to the persistence, where their transactions might fail in middle and the current user might be reading a wrong data. So isolation read uncommitted is not healthy all the times, but it depends where to use, and it's up to the needs. So isolation read committed very specifically tells that the only committed data has to be read by the transactions. This will help in preventing the dirty reads, but still repeatable and repeatable and non-repeatable reads are possible. Phantom reads are also possible. So isolation repeatable read, multiple reads of same multiple reads of same field yield same results unless modified by the same transaction. Here dirty and non-repeatable reads are prevented, but phantom reads are always possible, as the other transactions might edit the fields. That means if you mention for a transaction that it is going to do a repeatable read, then it is going to read that particular data for multiple times, and it is also able to get the updated data provided it updates the same row. But when other transaction tries to update it, the transaction might get rolled back. So we'll see with an example. The last one is isolation underscore serializable. This is the strongest way of securing the data, where the database will acquire the logs of a table or a row or a field. So because the strongest way of locking, there could be problems in terms of application performance. So this is the last resort where if you want to maintain a strict isolation levels, isolation serializable is a way, but it's not recommended if you are really bothered about the performance. Finally, read only. When you uh, specify this attribute, you're telling to the data source that my transaction is there to only there to read some data, so that the data source or database management system will make the transaction more efficient, or optimize the system so that the data is fetched as soon as possible. So read transactions will be given more preference, as the data will be needed as fast as possible. Transaction timeout. You can mention a timeout for a particular transaction where there are more number of steps that are involved, so that you can ensure that if a transaction is not getting finished within a particular time, it can get rolled back. So time critical transactions can be mentioned with the timeout count. The timeout countdown starts when a transaction is started. So this kind of timeout attribute is well used in propagation required. Propagation requires new and propagation nested kind of transactions. So in these situations, this timeout will work better, because these two will start new transactions and definitely will work with the transaction, and nested depends on the database. So last one is rollback. Rollback tells a transaction manager when to roll back a transaction when an exception occurs, but you should remember that the transactions will generally in Spring, the transactions will generally get rolled back when there is a runtime exception occurs. But still, you can go ahead to mention that whenever there is a checked exception, the transaction should get rolled back. So by mentioning what exception explicitly, whatever exception that occurs, you can tell to the framework that the transaction has to be rolled back. And if there is some other exceptions that are going to occur, you can also configure about no rollback, stating that even this kind of exception occurs, just don't roll back the transaction. So you can just configure for what exceptions the transaction has to get rolled back, and for what exceptions the transaction has to be just left as it is. So this is possible by using rollback attribute. That's all for this session. In the next session, I'm going to give an example about declarative transaction. I'm going to tell about the steps to configure the declarative transactions using Spring, and I'm also going to talk about how to use annotations as a configuration. In the third part of the Spring transactions, I'm going to talk about the programmatic way of transactions. So you can follow me on YouTube by subscribing to my channel Java 9s. You can follow me at Java 9s on Twitter. You can visit Java 9s page on Facebook as well. You can download this PPT from java9s.com website, and I have mentioned the direct URL in the description of this video. That's all for this session. Thank you. Have a great day.